Hi, my name is David Nataf, and for this video brief, I will be discussing my recent letter reconciling the Galactic Bulge Turnoff H discrepancy with Enhanced Helium Enrichment, co-written with Andrew Gould. It concerns the mean age of the galactic bulge, which is a very important parameter, fundamental parameter to galactic evolution, and recent efforts to determine it, and the discrepancy in the results of these recent efforts, which I argue is due to errors in assumptions as to the helium abundance. Photometric efforts, which are done by taking the brightness offset between the main sequence turnoff and the horizontal branch of the galactic bulge, primarily with HST photometry, have found that this brightness offset is indistinguishable from that in galactic globular clusters, implying an age of 10 to 13 gigayears. Meanwhile, spectroscopic determinations, which are done by measuring the surface gravity and surface temperature near the main sequence turnoff and the subgiant branch, have yielded ages of approximately 6 gigayears for the metal-rich stars, which is a factor of 2 discrepancy. I argue that this is due to an error in the isochrones, that their assumption of a scaled solar helium abundance does not apply to the chemical evolution of the galactic bulge. I will now show you figure 1 from my paper. In the top panel of figure 1, we see the spectroscopic plane, log G and TEF. I show isochrones from the Dartmouth Stellar Evolution database. And in those isochrones, we see the black one are the standard isochrones of scaled solar helium at F(h) of 0 with ages of 6 to 13 gigayears. And the red one is the helium enhanced track, F(h) of 0, 10 gigayears again. And we see that it is to the left of the black curve, which is the 10 gigayear standard helium isochrone, and that is why it masquerades as a younger population. Meanwhile, on the photometric plane, we see the exact opposite takes place. The helium enhanced isochrone has a main sequence turnoff fainter than that of even the 13 gigayear helium standard isochrone, thus masquerading as an approximately 13.5 gigayear stellar population. This causes photometric estimates to be overestimated. These two errors go in approximately the right direction, with the photometric estimates being too high, the spectroscopic estimates being too low, which is in the same direction as observations. We also discuss in our letter several other effects that should be present in the data and appear to be so, and we make several predictions that should be testable in the future as more data come in. Finally, we discuss phenomenological reasons why the bulge should be expected to be helium enhanced, as well as historical evidence from previously in the literature involving star counts in the upper red giant branch and the red giant branch bump that also indicate that the bulge is helium enhanced. Thank you.